There we go. And so we can go ahead and hop in now. Okay. They're just gonna have to do some troubleshooting. All right, so good morning, everyone. So today it's all about MAC switching. It's all about LAN switching, switching in the LAN. Now, as you guys know, I like to do a recap of the previous day before we even go in. So starting off in Notion, right? Going to Notion, going to our lesson. I'll probably change this to like week 1. We'll see. But let's scroll down and let's see, what did we talk about yesterday? We talked about virtualization. Hold on real quick. Let me exit out of this. Okay, there we go. So we talked about virtualization, where we're at right here. So let's bring this down to this screen. And we talked about virtual machines. What is virtualization, right? Making anything from created from software, right? It is not in its physical form. A virtual machine is a machine that emulates a physical machine, right? And as you can see, we have, before virtualization, a normal regular computer. And then after virtualization, we can have more than one instance of an operating system, right? How do I, maybe I should go to the next. But anyway, we talked about different types of hypervisors, 1 and 2, which allows us to create virtual instances, virtual machines. And a hypervisor 1 is the software that's embedded onto the hardware. It's the hypervisor that's embedded into hardware. Hypervisor 2 is is what you download. It's a piece of software that you download on your OS, on your operating system. So we all use type 2. It's more easier, but if we was to have a big company and scale, or, work for something big like PNC or somebody, then we would definitely be using type 1 hypervisors, right? They're physically configured onto the server, right? And then we talked about virtualization, different types of ways we use virtualization, whether we know it or not. And these are the 3 categories that they are, categorized in, which is IaaS, infrastructure as a host, right? That means that we'll give you the infrastructure, but you got to come with everything else, and that's like Azure or AWS. We got platform as a service, right? That means that we'll give you the platform, we'll give you the infrastructure, and we'll give you the operating system, the middleman, the firmware, and you do whatever you need to do with it, right? Which is, we're going to build applications, we're going to build things for our users to use, which would be, again, like Azure. And then we have SaaS, right? Software as a service, which everyone uses, right? That means that we're going to do the servers, we're going to have the infrastructure, we're going to have the platform, and we're also going to have the software created for you. All you have to do is use it, right? Create your profile and start using it. So these are the 3 categories. Please make sure you understand those 3 categories. Very, very, very important as you just go on in your tech life, right? Because this cloud is going nowhere. Virtualization is going nowhere but doubling. So even if you're not a systems admin or a cloud engineer, you'll still deal with these technologies, whether whether you're in tech or not, because we use Gmail and people are not in tech, they use Outlook, so no matter what, you're going to use these things. So it's great to know, what they got going on. Let's go back to Notion. And then 1.3, that's not where we're at. We are at cloud computing. And that was just a little blog about, what cloud computing is, right? It's a type of computing that relies on shared computing resources rather than having local servers or personal devices to handle, right? So we're cloud computing. We don't have, our actual mailbox with, physical mail coming into a Gmail coming into it, right? We have virtual mail coming into it. So, we're relying on other type of devices, other type of cloud computing devices to get mail, which usually we would get it in a, with a stamp in an envelope. Talk some more about virtualization, right? So you can kind of go in a little bit more, learn a little deeper with the hypervisor and stuff. And this is straight from the book, right? This is straight from the Cisco book. Definitely go through the chapter. But this is from the book as well. As you can see, some of my notes are, some of them are copied and paste from the book. And that's because the book just, explained it better than what I could explain it. So I just took that. But yeah, use a little more diagrams. And then, as you can see, we have the SaaS, software as a service, platform as a service, infrastructure as a service, and then examples of those. Okay. And then, yeah, that's really all you need to know. And then for a lab, we was go ahead and building our virtual machine. Hopefully you guys are doing that step by step. Like I said, tomorrow, Sunday, it's a study day. There's no lesson because it's still week 1. I don't want to go into week 2 until Monday. So like I said, I'll probably show you guys some things, or we'll see. We'll look around. But yeah, let's end that. And now for today's lesson, we're going to talk about switching concepts. Okay, let me exit out of that because we're done. Switching concepts. And let me really quick bring up, I have to download it in PDF form. And then I can have it here. Okay, so you guys will have 2 to look at. All right, so let's talk about LAN switching. Now, again, this is a little blog that I wrote. I'm not going to go too deep into it. I do want you guys to read over it. However, just a high-level overview, we talked about our different types of networks: WAN, MAN, CAN, LAN, right? And LAN, LAN switching is local area network switching, right? It is where we have data that's being switched, that's being transmitted locally, only in our network, not in the internet. So right now we're only going to be talking about layer 2 because we talked about the physical layer. We talked about all the devices that you need, as far as like the computer, the router, the switch, the servers. We talked about all that. So that was physical layer 1. Now we're on layer 2. And that's where section 2 more is going to come into as we deep dive into it. This is kind of like, a prerequisite. So as we talk about layer 2, it's all about MAC addressing, which is all happens in LAN. It all happens in a local area network. Because there's no need to, if you look here, this is a LAN. There's no need to have a router unless I want to go out to the internet, unless I want to go out to my WAN, my wide area network. So since we're just staying within our own layer 2 network, the switch is all we need. And that's what we're going to talk about, how does switching happen in the LAN. All right. Now, when we have our switch, we are always going to be talking about networking in an enterprise level. We're never going to talk about it in a home level or a personal level. So when we talk about switch, when you hear these devices, 9 times out of 10, you're not going to have a switch at your house where, you are using to, switch your data around to other people in your network and then hop on your gateway, your router and stuff. Like most of the time you have just your Wi-Fi box, which does all that for you because you're just in an apartment or you're just in a house or you're just in a very small building. So all of this networking stuff that we're talking about, it always comes from an enterprise level, a level of, tens of thousands of employees. Okay, so with that being said, we have our switch, and our switch is our access point. It allows our devices to gain access into our network. Okay, so basically right here in this area, I kind of did like a little history of switching and kind of more on topologies, right? I guess we can go in on it. So in the beginning of the earliest recorded LAN switching that was ever found wasn't actually switches, they were just cables, and they were known as 10 base 5 net thick net or 10 base 2 thin net, right? So either you had a 10 base 5 thick net cable or a 10 base 2 thick net cable, and they were just to connect computers together. They were like coaxial cables, like really thick Ethernet cables, but they were coaxial, right? They were really thick. Whether it was 10 base 2 or 10 base 5, they were still thick. It's just 10 base 2 thin net was a little, thinner, but they were just cables. And that's how we were able to switch data in a network in the beginning times. Now, it was literally, like you see here, a physical bus topology, right? Every single computer was connected to that cable. And as you can see, there's a cable in, and then you see all the computers connected to it. They will literally like clamp something into the coaxial cable, so that computer can get some data transmitted to it and from it. Obviously, that didn't work out well because you clamping on to electricity and stuff. Obviously, it's not going to last long and intermittent. It's going to be crazy. But that's what they had in the beginning. So it was like, that's how we switched in our local area network. One long cable, and everyone just connected to it. Now, as technology started to advance, a hub was created. Now, a hub was still logically a bus, right? It's still, everybody's still connected to it, like in a straight line per se, but physically it was a star, right? So it had the hub in the middle, and physically that was like if you're in a classroom. So physically you would be connected to the classroom's, hub, or you could say, whatever device you want to connect to. And then, through our cables of our computers, we're all connected to that. But still, how it worked was still a bus type way. It was still like, going one by one, serving A, and then going to the hub, serving B, then going to the hub, and serving host C, going to the hub. It's just like in a straight line. It's just physically we didn't have to clamp on to this long cable that went around the classroom. We had an actual device that our cable could just plug into, So that was the hub. Again, it came out to be more mobility, right? To have more mobility. Now, hubs, they was really great, but they had collision domains, right? Collision domains is what? A shared area where collisions can happen. So when we're talking about sending data and receiving data, we want to be able to have like a freeway. If a freeway is one way and you have people going up, two different directions, that's a collision domain. How do we separate that? Well, for us in if we're building roads or something, we would have lines, or we would have a barrier, some type of medium or something. But as far as in computers, what we'll have is better really technology. So instead of having a hub where it's that one interface where, again, collisions happen because it's a shared media, we had to, go up in the world. Now, as we go up in the world, we have something called a bridge. Now, a bridge actually separates collision domains, because a hub is one big collision domain. As you come up here, you see it's just one big collision domain. It don't separate anything. But when a bridge came out, the bridge actually separated different interfaces, different ports, as you can see, to where now we have more than one collision domain. So bridges, if I'm not mistaken, let me read some of this. I think bridges have 2 or 3 collision domains. What does it say? The hub is replaced by bridge. The bridge ended up having memory as well. But it also has more collision domains, 1 per port. So yep, a bridge had more collision domains. So each port was a collision domain, and it had 8 ports. So therefore it was 8 areas that you can, access. As far as a hub, the whole thing is a collision domain, right? So no matter what you plug into, it's the whole thing is all together. It doesn't have any type of intelligence to separate this data. But the bridge was created to get some more intelligence. So it has memory, so it's able to store MAC addresses, the burnt in device, the burnt in address of the actual device, and it had more collision domains. Okay, so we're a little bit more. So the bridge was good. However, it wasn't that scalable. So as we come today, we have switches. And switches say, hey, now it's like a bridge, but it's more scalable. We have way more ports. We have like 48 is a switch. Oh, switches can have hundreds of ports. I'm used to the ones that have like 48 ports. But yeah, switches can have hundreds of ports. So that's hundreds of collision domains. That's really great. And then it has a lot of memory. So it expands the memory than the bridge and the hub. And it supports not only MAC addressing, but VLANs, virtual local area networks. So now we can not only separate our collision domains, we can even separate our networks to even have even more collision domains, so it's like, next level, a hub on steroids is what the switch is. And there are 2 types of switches. There's layer 2, which does MAC addressing only, and layer 3, which does MAC and IP addressing. So a layer 2 switch, you can only switch traffic, via the MAC address. So that means it cannot route via the internet. It can only stay on layer 2 of the TCP/IP model. And then, or you have a layer 3 switch, right? And layer 3 is what? That means IP addressing. That means not only can it switch data between locally, it can do it over the WAN. It can do it via the internet. And this is what a real switch looks like, 16 port Cisco L2 switch. So you may see these out in the field. I mean, you definitely will at some point in your career. I know I didn't, actually I saw a switch when I was like doing like an internship, kind of, I was in the Ashton program, but we was playing around with it. It wasn't nothing serious. Actually on the field, like my own contract, I haven't seen a switch. I went into the office one time. That was in the beginning of the pandemic. I went in for like a week, and they had switches. They had a whole bunch of network equipment all around the device, all around the department. We were kind of like in the basement of the hospital, so that's where we worked. So it was like a lot of like different devices there, some working, some not. It was just all, whatever. But I've only did that. I was only there for like a week, maybe 2 weeks. And then I've been remote for the remainder of my career as an IT. So I really honestly haven't really seen switches or haven't really dealt with them physically like that. I virtually deal with them, so, put that into perspective. But so yeah, so LAN switching, how does it work exactly? So we're going to actually get into the meat and potatoes, right? So switches forward Ethernet frames, okay? Switches forward Ethernet frames. An Ethernet frame is encapsulated data, okay? So switches forward frames, and frames are data that's been encapsulated, right? And this encapsulated data is basically layer 2 data of the OSI TCP/IP model. So what is that layer 2 data? The layer 2 data is MAC addressing. So we go down here, right? This is kind of like a little diagram. You'll kind of see this a little bit. Let me go. Okay, so encapsulated data. As you can see, this cable, this is the network media, this is the cable, this red line represents the cable. And then sent through the cable is ones and zeros and ones and zeros and ones and zeros. These ones and zeros make up this readable language that we call frames and packets, right? Encapsulated data. It's going to have this information. Now, it's in ones and zeros, but we have to interpret it in the way that we know how to interpret it, which is, this type of English language. So these ones and zeros will be, like I said, encapsulated in this frame. And this frame has a MAC header, right? An IP header, a TCP header, upper layer data, and FCS. Sometimes it's frame check secrecy. Sometimes it's the cycle redundancy. Just know it's for errors. It's checking errors at the end of the frame. Okay. So this whole block right here represents a frame. Okay. So switches, they take frames and they switch them to the device that needs to go. How do they know what device to switch it to? It starts right here, the MAC header. Well, in this whole little block right here, since it's all blue, it will have the source MAC and the destination MAC. Okay. It will say where device it came from and what device it needs to go to. That's next in line. Okay. And then after that, it'll have the IP header, we'll have the IP information, what IP it came from, and what IP address it needs to go to. And then they'll tell you how to transmit this data. Is this data transmitted through a connection, TCP, or a connectionless, UDP? You're just gonna blast this data out. And then once you blast it out, we need to see, is it going to take 5 seconds, 5 minutes, 5 hours? That's session. And then after we do session, we need to see, okay, so how is this going to look? How is this going to, is it encrypted data? Is it, what's going on? What's the presentation of it? And then of course, we have application where's this data accessible? Is it accessible on YouTube, Gmail? Is it an email? Is it a video? What's going on? And again, this is literally the frame going through the network. So whether you want to watch YouTube channel, this is what's happening when you want to watch YouTube. When you say, I want to go to, whatever, you type it in and it brings you up the results. This is what it did. It went through these things. And it did it in like less than a second. And that's what we're learning. We're learning what happens in less than a second. It's just, and it's a lot. And they're like, yeah, so it's a lot that goes on. So I kind of just read that. Switches use logic that's based on source MAC address and destination MAC address to forward the frames. So they say, who does this belong to, right? Just like an address, okay? Switches have memory, which holds a MAC address. So you can look at a MAC address as like I said, when you have an address like 123 Main Street, New York, 77051, right? That's your address. Now the MAC address is 123 Main Street. Your IP address is New York, 775, whatever the zip code is. Okay. So switches are only going to forward, they're like mail carriers that's only going to send mail that's local in their area. They don't know, they're already in the city. So the city is irrelevant to them. The zip code is irrelevant. They're just going to, oh, this Main Street, oh, this 123. That's all they care about. That's all switches care about is, what's local in my area. I don't know. I'm already in New York. So who cares about what city and state? Because I can't go nowhere outside the city and state anyway, and maybe if you're in a big city to where you may have 2 zip codes, right? It's probably just in that neighborhood, right? So switches, it's just like the mailman only can send mail or deliver mail in a specific neighborhood, like only on the west side of Houston. So they only know those street names, anything. We don't need anything else. So kind of look at it like that, like it's very on a local basis. So switches have memory, which holds MAC address, right? So they have a MAC address table. So when you first when you first get your switch, there's no MAC addresses on the table. But when you plug devices into the ports of the switch, let me see if I can use my pen. I want to draw something, but it won't let me. Okay, whatever. But switches, right? They have this MAC address table. And when devices get plugged into the switch, then their MAC address gets recorded to the MAC address table. That can be automatic. You can configure that to be automatic immediately when something plugs into your switch. You can configure it to be like automatically record that MAC address, or the switch will get the MAC address when that device is plugged in, but it has to send data through the switch in order for the switch to record the MAC address. Either or, you can configure it how you want. Right, we'll get into that because that gets into security. We're going to talk about port security, where we can, configure our switches to look at MAC addresses and see if it belongs to our network, if it can switch data in our network or not. But that's for security, So right now we just care about a switch and the logic that it uses. How intelligent is the switch? The switch is only locally intelligent. It's only going to say, hey, 123 Main Street, I know 123 Main Street is down the street. I'm going to go down here and deliver the mail. Whether it's 123 Main Street, San Francisco, California, or 123 Main Street, New York, they don't care. It's 123 Main Street. So it's the same thing with the MAC address. And again, a MAC address is unique. So there's not going to be two of the same MAC addresses, no matter what in the world. So it wouldn't mess up anyway. Now, switches only forward data to hardware addresses. So that means that if the destination is not in the local network, the switch will drop it because the destination address is not reachable, right? They do not route traffic. They forward data. They just say, let me read you, huh? Okay, now L2 switches will route IP traffic. That's a different logic. And we'll get into routing. I think that's week 3. We'll actually talk about routing, but switches do not route. They forward, okay? They only forward, all right? They switch. Like these are the same words that we use, and it's kind of like, again, it kind of goes in tandem of what it is, kind of like self-explanatory in a sense, if you make it, kind of logical. Now MAC address, we kind of already know what a MAC address is, but I kind of went in a little bit more here. A MAC address is short for Media Access Control. It is a unique identifier assigned to a network interface controller, a NIC, right? Your NIC card that is tied to your computer for you to connect to a network. A MAC address is hard-coded on the NIC by the computer manufacturer. Like I said, everyone is unique, has a unique MAC address. No one has the same MAC address because the MAC address is from the manufacturer to say, okay, this is one of our devices. We made this at this date. It is, this number, right? Because everything is accounted for. Nothing is double, right? So that means that everyone has a unique MAC address on every single device in the world. Now, with that MAC address is hard-coded onto your NIC. You have a computer, unless you build computers, the NIC already comes pre-configured, pre-installed on your computer, but you can buy separate NIC cards and put them in, it's pretty fun actually, but yes, so it's all specific, it's all unique, and it's, to your device. So switches only care about the MAC address, which is Immediate Access Control. That's what MAC stands for. I suggest you write that down or understand that because that is actually an exam question, believe it or not. They say, what does MAC stand for? And they're going to give you all these other things that's, MAC. But if you don't know that it's Media Access Control, that is a very easy question you got wrong for no reason. So write that down. So back to Ethernet frames, right? Switches forward Ethernet frames. And they forward Ethernet frames based on their MAC addresses. Switches have memory, so they store MAC addresses of the computers on that network, right? And they store it on, like I said, it's called a MAC table. We'll get into it, but for right now, I just want you guys to understand the fundamentals, because once we get to week 2, which is Monday, and on down, we'll definitely be, doing a lot of commands because that's kind of practical work, right? So just for right now, as you can see, we have a screenshot of what a MAC address table is. So we'll go into our switch, right? We'll go into enable. And once we go into enable to get into our privilege exec mode, we'll be able to do the command show MAC dash address dash table. And what it's going to do is going to populate what MAC addresses the switch has stored on its MAC address table. And it'll give you the VLAN that is connected to. All MAC addresses is connected to VLAN 1. VLAN 1 is the default VLAN. It will always be there. We will talk more about VLANs, so no fret. But just know that VLANs is what you're going to see, and everyone is always going to be connected to VLAN 1. Then you have your MAC address. As you can see, hexadecimal MAC address. You have your type. How was this MAC address learned? Was it dynamic or was it static? And then we have the ports. Where is this MAC address located? Where is it connected? Where's the access that is coming from? Fast Ethernet 0/1, FA 0/1 port, FA 0/3. So now if I don't know this MAC address, or this MAC address just been sending crazy stuff and we don't know how to stop it, or we did stop it, remotely, now we have to go and find it, or we're trying to see what is this connected to our network, it's not doing anything, then we'll say, okay, well, this is the MAC address, it's connected to FA 0/1. Somebody's maybe at the data center, or maybe this switch is, located at an office building. Okay, so you would direct someone to drive up to the office building and, go check out this switch, look at port 0/1 and see what's going on, what's connected, follow that Ethernet cable and be like, oh, this is this switch and whatever, So that's something that you can do, you can use this MAC address table. And I've done that before, had to find a device using a MAC address. So definitely interesting. MAC learning, right? MAC learning is when a switch learns a MAC address either statically or dynamically, right? The type. So dynamic is when a host and a switch is directly connected and the connected host sends a frame so the switch can record the MAC address, right? Remember I said that, hey, the switch is only going to learn the MACs either connected right when, I plug it in, or when I send data. When one device sends data to another device and it has to go through the switch says, oh, well, I haven't heard of you before. Let me write you down. Okay. Now we have statically, which is when you tell the switch, you go into the switch, right? We go into the switch CLI and we say, port sticky. I think that's the command. Port sticky, and you put in the MAC address. No. Let me go back. When you put in the MAC addressing. So again, that's security port sticky port. I forgot what the command is, but it's static. We're going to statically assign it. Oh yeah, port using the sticky command. Yeah, something like that, port sticky. And then MAC aging. MAC aging, exactly kind of what it sounds like, just like MAC learning, is the amount of time the MAC address stays on the MAC address table, right? The MAC, when the switch collects the MAC address on this table, it starts to collect, especially if, things are being, especially if it's like a 1,000 port switch or something. But are all those devices active? Are all those devices, should they be there? Like what's going on? So we have certain configuration, certain settings we can set. We can set the timer to 0 and we can disable MAC aging and discarding, because what MAC aging do is we set a time and it specifies and it says, hey, whichever MAC address that's, the oldest needs to be discarded. So we can say, hey, the default time is 300 seconds. We have a range to 1,000,000 seconds. I don't know what that is, but we have to do it in seconds. So we could say, hey, keep this MAC address on the switch's table for 300 seconds. And again, that's default, so we don't have to do anything. But we can set the range, or we can just do 0, and the MAC address will stay on the table until we permanently move it, until we as the administrator go in and move it, which is good. And then again, it's bad because then your MAC address table can get so convoluted. It can get so many MAC address entries on there to where now your switch is not switching traffic fastly as it should, because it has so much data in its memory. So we kind of want to, it's good for us, but then again, it's not. And again, that's why they hire, multiple people in the networking department, because not everyone can monitor everything. So kind of good for you. Now, we talked about MAC addresses, right? What a MAC address is, where it's stored on a MAC address table, which is on the switch, because we're talking about switches. And then we have the switch will learn its MAC, whether dynamic or statically. And the MAC definitely has an aging process. It's not going to be there forever unless you set the timer to 0, which can backfire if you are, if the MAC table is accumulating a bunch of entries. Okay. Now, going back to Ethernet frames, right? The frame. What is the frame? Look at this. This is the frame. The frame. Think of it as just a rectangle with sections of data, and the data is the sections of data is layer 1, well, layer 2, layer 3, layer 4, layer 5, layer 6. That's all. Saying that's all is in the frame. That's all in ones and zeros. And we decode that to be what we decode it to be. Now, there are 2 types of frames. There's a unicast frame and a broadcast frame. The unicast is one-to-one connection. It's just saying, hey, I want to send something to John, right? A broadcast frame is what we call flooding. It is me sending it to everyone, right? What I do want to show you here is CAM table. Now, sometimes in older text, you may see CAM, then you see MAC. It's just the same thing. MAC and CAM are the same type of tables. They are for your MAC address. CAM is just the older version of saying it. I forgot what it stands for. Let's see. CAM table. Content addressable memory. It's the primary table used to make L2 forwarding decisions. What does that sound like? Sounds like a MAC address. Oh, CAM, content, addressable memory table is presented in all Cisco catalysts for layer 2 switching. It is used to record a station's MAC address and its response. So yes, it's the same. It's just MAC address. Again, it's just the older way of saying it. So you may see that come up in different readings. Don't get too confused. It means the same thing. So CAM and MAC is whatever. And what's crazy? That may be an actual answer. I mean, a question on the exam. It may say, what is like a MAC address table or something? And they may give you CAM and a whole bunch of other things. Or they may say, what's just like a MAC address table, or what's just like CAM or something. I don't know, but it's definitely going to be something to where they're correlating MAC and CAM together to see if you remember, if you know the difference or not. So, and that may or may not be on it, because again, every exam is different. I think they have like 7 different versions of this exam. So the exam that I took may not be the same exam that you take. However, the way that it is structured and laid out will be the same. It will still be multiple choice. The questions will just be jumbled around, right? Or you may not get as many IPv6 questions that I got, but the percentage is still the same. Anyway, moving on, let's talk about ARP, Address Resolution Protocol. This protocol is used to help create layer 2 frames, right? This protocol is used to help create layer 2 frames by looking for the destination's MAC address using a flooding technique, okay? So basically what happens is the switch will get, well, actually before a switch, let's say the IP, let's say the computer. I want to send, let's say I'm in a classroom and I want to send, one of my classmates a funny meme. Now, before I can send them a meme, the frame has to be built, right? I need the source address, the MAC address, I need the source IP, I need all of that information. But obviously I don't have that information, especially if I've never sent, one of my peers a message before, right? So how do I get that information? I know my information, but I don't know their information. So what I have to do is I have to broadcast. I have to say, hey, who's, let's say I have their, let's say I have their their student ID number or something, or whatever it is to identify their computer. Let's just say I have their computer, which is O1 and I'm O5. And I say, hey, who's O1? And then O1 will come back and say, hey, I am, and they'll probably say this right here, I am this IP, 192 with whatever, they're identifying yourself. So since they were able to identify themselves, I can now finish off my frame by putting in their information. So I know my information, I put their information. And now when I send it out from me, all the devices know to take it to, computer one. That's the logic behind address resolution protocol, right? It's 2 steps, request and response. And all it is saying, hey, I need to finish building this frame, this Ethernet frame, but I need some information. I don't have all the information. So how do I get that information? Because it's not stored on my MAC address. It's not stored in any of my memory. How do I get it? I have to do a flood. I have to do a broadcast. What do we say? A broadcast equals flooding. Address APR, ARP, I don't know why I say APR. ARP, address resolution protocol, is basically a broadcast. It uses a flooding technique, right? Broadcast flooding, the same thing. And it yells out, whose device is this? Now, it's between IP and MAC. So if I have the MAC address, I'm looking for an IP. If I have an IP address, I'm looking for a MAC, because I need both of those in order to send this frame to the destination. It cannot leave anywhere until I have both the IP address and the MAC on the frame, because this stuff is going to get broken down, right? Because once the frame, let me go back up here so you can kind of see. Once this frame, so you see how it's built, it has the MAC, it has the IP, the TCP, all the layers. That's all the stuff that we've added, and we're about to send it to the cable. Now it's going through the cable. Now it's to our destination. So it's through our destination's cable, and now it comes through the application, actually, when it gets to our destination. And then it goes down to the application. Presentation actually gets broken down, right? So at the end, we have our MAC address to where it's like, okay, this is where it belongs. But I still need my IP, because how do I know that it's actually for me? I know that it's 123 Main Street, but what if it says, San Francisco, California? I'm in New York, New York. So clearly this is not the 123 Main Street for me. So that's why the IP is needed. Okay. So when we talk about ARP, we need both of them to ensure that this letter gets to the house it needs to get to. So if I have, the 123 Main Street, I'm about to yell to everybody that can hear me. What's the city and state and zip? That's why a lot of times they ask you for the zip, because, I need to know exactly where this mail goes to. I understand it's Houston, Texas, but what zip code in Houston, Texas? So same thing with ARP. Here's a little reading right here, so definitely read it if it's still kind of confusing, but just know it's a broadcast, and someone's going to say something. One computer's going to say something and say, hey, that's my IP, or that's my MAC address, or whatever. The name says it all. Address resolution protocol. It is a protocol to resolve an address. That address may be an IP or it may be a MAC. I don't know, but it is to resolve an address. If you can just remember it like that, then you should be good. Now, switches, they forward frames 3 ways. Okay. The first way is store and forward. Now, store and forward, let me see. Oh yes, it's only Cisco based. I was going to say, I don't know if these are only Cisco ways of switching, but most of this, like I said, this information is Cisco based. So this is how Cisco deems networking is managed and configured. Now, when you go out and you work on other types of equipment outside of Cisco, like Juniper or Avaya, those things may be a little different, but the concept is still the same, right? A switch is still the switch, regardless who puts their name on it, right? But the technology in that switch may be a little different. The commands that you put to do that said technology may be a little different. Okay, so just put that in mind. And again, why we are viewing Cisco and not Juniper or Avaya is because Cisco is the leader in IT in the world. So if you know this, you have world knowledge. As far as any other of those vendors, you may just have US knowledge, or you may just have the, Western knowledge, Western hemisphere knowledge. Why do that? Let's have the world's knowledge. Cisco is the leader. So learn Cisco, right? But moving on, switches forward frames 3 ways. Now, the first way is store and forward switching. It is when a switch receives a frame. So the switch is connected with, with the Ethernet ports, ones and zeros through the cables. Now, through those cables, a frame will come through its port, and the switch will receive this frame and store it. And they'll store it until it gets all the frames, everything that it needs. They'll store until it's like, okay, is this all the message? This is hi, mom. This even the picture. What else you got? It's a PDF that you got too. Like, send me everything. All right, then it's gonna wait. Okay, that was everything. This is gonna check for any errors. Is there any errors in this frame? Is it good? Does it have anything that seems suspicious? No errors. Okay, now I can send it where it needs to go. That's storing forward. There's only Cisco devices uses this. Okay. Now the second type is cut through switching. So a switch going to receive that frame, that same frame, but once it receives that frame, it's going to immediately forward the frame. It's not going to wait for the picture, the PDF, it's not going to wait for anything else with that frame for any more messages. It just takes the frame, send it out. Takes the frame, send it, looks at it, send it out immediately. Cut through. That kind of sounds like how it would, right? Cut through. So it's just going right through. Store and forward switching. That sound like I would store it until I finish getting everything, and then I would forward it. That's how you should kind of remember these things, kind of it's in the name. And if you can memorize it as like, it being in the name, then you will definitely go far on the exam. So storing forward, right? We're storing the frame until we get all the frames, everything together, all the data, and then we can forward it. Cut through, we just get the frames and it just gets sent out. Whether it is completed or error-free, don't matter. The minute the switch gets something, it's sending it right out. And then the third way is fragment-free switching. So this is like a store and forward and a cut through, then combined and made a baby. So what they do is the switch will take that frame and it will only check the first 64 bytes, right? 64 bytes. How many bits are in a byte? I think 8. I think there's 8 bits in a byte. I don't know. Let's Google that. I don't want to start just telling y'all whatever. How many bits are in a byte? 8. See, I know what I be talking about. Even though I don't do this all the time, I know what's going on. So let me go back here. So yes, 64 bytes. Okay, the first 64 bytes. Why just the first 64 bytes? Because most errors come from the first 64 bytes of data. All right, so the fragment free, we're just going to check the first 64 where most errors occur. If there's no errors where it's commonly errors, then we could just go ahead and just send it on out. We won't have to check the whole thing because we just want to, send that baby on out. Which one would you set up for your Cisco switch? Store and forward, I believe that is defaulted. Now, if you feel like you want to switch it some other type of way, you can change it up. I've never changed it. I've never seen anyone change it. I don't even think I don't know if you can change. I think you actually have to buy certain switches that have this technology. Not sure, but what you should know is that Cisco switches have 3 type of ways. Well, switches period have 3 type of ways. It's just store and forward is solely used on Cisco switches. Okay. So this kind of, again, self-explanatory, right? So store and forward, cut through, fragment free. What's a fragment, So hopefully you get that. And here's a little diagram. You can kind of see how, this computer, let's say computer H2 wants to send data. The data is 4,500, megabits or whatever. I don't know what the 4,500 is. And then it's going to get sent through the wire, but it's going to get sent through the wire broken down. Just like, see, this is more data technology, because I know with voice technology, it's kind of the same thing. We have it in our frames, and in our frames, we will have it in like, hello, how are you? can I have your name, please? And that's all in, the different types. That's all in broken up in frames. Even though when we're hearing it on the phone, we hear it seamless. Hello, how are you? What can I do for you? You're not hearing it broken up unless, the quality is bad. But it's all getting, that's how the switch and how the router receives that audio is broken up into pieces. So it's the same thing as with data, right? We have this whole thing of data. Hello, how are you? But hello's being sent in 15 megabits, and then how are you being sent and 15 and just keeps breaking down. And the switch, depending on which type you have set, is either going to keep that whole message, like, okay, hello, how are you? How can I do? Okay, that's the whole message, and then let me send it out. Or it could just say, hello, send it out. How are you? Send it out. It's going to get to the computer, to the destination all at the same time. It's not going to be broken up unless the quality is bad, which means you got to start troubleshooting to see, is it the interface? Is it, the duplex speed, right? That's when we start troubleshooting. However, they're going to get all that. So this is kind of how, data gets switched to the network. Where 4500 is kind of broken down through the switch. The switch is going to send it through either wires. It don't have to be the same wire at the same time, right? It goes to the switch. Depending on what this switch got on, is it going, store for what it's going to do? And then it's going to, give it to the destination. So kind of like a little visual there. Now, let's go in on the Ethernet frame a little bit. Now, an Ethernet frame, let me see. Okay, boom. So an Ethernet frame has these things here. Let me move my cursor so you guys can see. Okay, Ethernet frame. This is something like it. It is like a rectangle. Okay, we have an Ethernet and we have an IEEE 802.3 standard, which is Ethernet as well, but it's their standard. I would say you definitely need to know the difference between these, just like the OSI and TCP/IP model, same difference. It's the same thing per se, but it's has a little difference in it. And that's, again, excuse me, that's depending on what they're asking you. And this is an exam question, because we're never gonna do this in the field. Like, is it an Ethernet or an IEEE 802 standard? Like, no, my goodness, it's a frame. But again, if you're taking the exam, you have to know the difference. So let's break this frame down. This frame is going to go in, starting with the preamble. The preamble just is letting the system, whether it's a switch, well, it's a frame. So let's keep it on layer 2. So it's going to let the switch know that a frame is coming. So we need to start syncing up, because that is about to start coming in, right? So it's 8 bytes, which is, 8 bits and then whatever. So it's like 80 bits. So 8 bytes is telling the switch, hey, something's coming. So you should probably gear up. Let's sync up. We're about to get some data coming in, right? Then we have the destination address. The destination address is the destination MAC address. It identifies who this data is going to be sent to, right? It's the receiving device, whether it's a server because I want to go to google.com, or whether it's my mom because I'm saying, hey, happy Mother's Day, right? That's 6 bytes. And then the next 6 bytes is your source address, identifying who is sending this data. It is me. It is I. And then 2 bytes, we have type. Type is the protocol. Is it V4 or V6? And then we have the data that now comes into the switch, which is 46 to 1500 bytes. Okay, so that was in that other diagram. It was all in bytes. Okay, so that data, we call that the payload, right? And that contains the L3 packet. And the L3 packet will get more into packets when we get to routing and L3, because we're just on L2 right now. But it provides all this L3 data, okay? And then once it processes that, it'll come to 4 bytes of frame check frequencies, FCS, or sometimes they call it CRC, cycle redundancy check. And again, it's just there to check errors. It's just there to be like, all right, error checker, everything good. Go ahead, send it on, boss. The IEEE 802.3 frame, this is a frame with the switches received. It's the same thing. The only difference is they have a SOF. a start of frame delimiter, which is basically just saying that the next byte is the destination address. So not only do you get the preamble, right? Because the preamble right here is 8 bytes. But for the IEEE's frame, it's 7 bytes because they want that last byte to say, to have the message, hey, the next byte is the destination address. Like it's basically it's telling that device what's about to happen next. So that's really it. Oh, and then they have the length instead of type is length. I don't know. I'm gonna say it's still whether it's IPv4 or IPv6, or maybe both of them. I don't know what the length is, honestly. Just know that you should know that that's the 802.3 standard, right? You could probably look that up so you don't get confused if you're gonna take the exam. Now, let me see here. Basically, this is kind of the same thing, frame, just in a different type of diagram, right? We even have the packet layer 3. Inside that layer 3, so we have our frame, which is the MAC, layer 2. And inside our frame, what do we have? We had data. We had this data. This data is the IP stuff. It's the layer 3. Now, when we get to layer 3 in routing, we'll actually go into packets and we'll see that the packet includes layer 4, right? Which is TCP IP, which also includes layer 5 through 7. Is it HTTP, FTP, DHCP, DNS? So the packet that's inside of the frame of encapsulated data is, the rest of the layers, right? So the packet, the frame is just encapsulated data. It's data from all these layers here. And it's telling exactly what needs to happen, how it needs to be displayed. Okay. And we already talked about collision domains. Oh, this was a good one. Here's a visual collision domains. I don't know if I gave this to y'all, but half duplex, full duplex. Full duplex is send and receive. Half duplex is, you can only send or receive. Really good, really good. Tells you even more where we're at. Oh, this was like a double. Oh, I was just adding in more data here. So that's probably why it's doubled. Okay, cool, cool, cool. Let's go into this one here. I think it's just the same information, just in like a yep, frame flooding. Hey, I need someone's MAC address, whatever. MAC address, MAC aging. Yeah, it's just giving you diagrams here. And like I said, if you feel like, hey, I brought up yesterday about tech writing. If you actually like thinking about tech writing, you can take this and tech write to it. You could just take this right here and tech write to it and say, okay, well, Ethernet frames and IEEE 802.3 frames, and start writing about that and the details of how they're different and what's the difference between them. Like, and then put some pictures in it, put your name on it, spell check, put that thing on your resume. Say, I'm a tech writer. And for legitimacy, you definitely can send that over to me and I can make sure that it's all correct and right. And I could put that on my course and be like, hey, here's a nice blog from one of the students. Thanks for, making this more easily readable for new students coming in. Hey, however how you want to do it, I'm here for you guys. But yes, that is LAN switching. It is literally just the switching Ethernet frames through what's on our local network. It cannot route out the internet. We're not there yet. We're still just in our local area. Okay. And we're in the switch for these frames, switches these frames via MAC addressing, via our 123 Main Street. Don't care about anything else. What's your street? Let me get on your street. Just like how back in the day, you could just dial the number. You didn't have to dial the area code. You could just dial, 707-9293. But now you have to dial, the area code 770-707, So it's kind of like that, right? The area code gets us where we need to go, or even when you have to press 1 to do like international and stuff, same difference. We ain't out there yet. We just locally, so we could just do our seven digits, 7-digit calling. But yeah, that was it. As far as Notion go, um, we did the network labs. No real labs today. I was gonna say find your MAC address. That was gonna be probably something cool. Find your MAC address. Can I get into labs? Probably, maybe even on your network and packet tracing, you can find MAC addressing, but you don't really have to because next week is all about that. Just make sure that you're caught up. I would say use today, tomorrow to catch up. Binary is so important. Subnet is so important. I don't want you guys to move on to section 2, to week 2, and you don't know how to subnet. And all you have to do is find the network ID, the broadcast ID, and the usable IP ranges. As long as you can find that 3 times without messing up, then you can move on. If you can't do it, you need to not move on, because honestly, you have to get that down, at least to that level, at least to that level, please. Build a virtual machine. I suggest we all build that virtual machine. Again, tomorrow we'll definitely have it, but please, build that, especially if you're into cloud computing. That will be great on your resume to just say that, you built an Oracle machine on like some local behavior, and, write a little blog to it, and, pump yourself up. It's really not that hard to get this 100K. And then boom. And then flashcards, obviously, we love the flashcards. And LAN switching, here it is. What layer does a switch operate on? That's pretty easy. Layer 2. And that is an exact question, from the exam. As easy as that sound, as easy as that is, imagine all these questions, all these flashcards that we have now is on the exam. Yes, that's pretty easy, but you have to memorize. You have to know, like, okay, layer 2. It's something that you have to know. So I'm getting it. So know it. But I'm here for you, like I said. And that's it. That's all for today. So, yep, that's all for today. So did anybody have any questions, comments, concerns about anything? Let me stop sharing. Anything?
Yeah, question. Okay, when you said something about an intern, where did you intern at, like, to get more hands-on?
It really wasn't an internship. It was more like I will train you to do this for my job, and I'll pay you very minimal. I called it an internship because, like, again, I really wasn't getting paid that much. I was just learning.
Right.
They're called Ashton Technologies. I can actually send you some information if you want. I'm kind of plugged in with them, to put people onto, their platform. So, if you're interested in them, you definitely can check them out. You have to study at their location, whether that's in Minnesota or that's in California, and they choose what location you go to. You don't get to choose.
Okay.
But it is very intense. Adele, she's not in here today. She's usually in the lives, but she just came from Ashton, and she wasn't able to make it through because it was very, very intense. And that's because they don't break it down how I break it down. They tell you stuff in very high level, and a lot of people don't succeed from that program, honestly. And I even failed. I only came back because I got my CCNA, so I was able to, meet them at their level, even though they knew that I didn't know this information, when they first hired me. So I would suggest you go through this course and then hop on, if you want to do it that way, hop on to Ashton. And so while they're teaching you and you're kind of getting paid a little bit, you won't be totally lost. You'll already have heard all these terms and been in the CLI, so you can immediately go and do what you need to do. But again, you're starting off at a very, basic level as far as pay. I think your first contract will probably be no more than $20 an hour, which is it's good for learning, right? It's good
Right.
for
Yeah.
a good
Yeah. Yeah.
experience,
That's
but
all I'm for right now. Just learning,
yeah,
learn, you know?
just to learn. But the amount of work that you do, you'll definitely get, you'll almost have like resentment because it's like $20 an hour and I'm an architect. I'm an architect. There's no way in hell that this is,
Right.
so and again, you may have a cool first contract to where $20 do suffice it because you're not doing anything. It's just a real gamble with them. So I would rather get people to get this information first and then go mess with them because I don't want you to, fail in that program,
Right. Right.
because
Right.
if you go out there and even if you do learn stuff, if you don't make it through the program, it's kind of like, you could have just did this on your own. Because once you make it through the program, then you get the contracts, then you get the stipends and you get to travel the world and stuff. But you have to pass the program first. And it's
Right.
so hard. But no, Fred, like I said, continue going through this course. Once we get down to the bottom, or once you feel that you are, confident enough, we can definitely set you up with Ashton for sure. I can email my people over there, email them your resume, and you guys can talk and have a conversation.
Okay. Thank you, Jess.
Yes, yes, yes.
Yeah, I'm gonna keep. Yeah, right now because okay, so I was supposed to leave today to go do some contract work for my job, but then they postponed it. So I'm like, yes. So
Exactly.
I can actually like concentrate on
Mm.
this now. So I'm like, okay, cool. I'll take my little 2 months off, 3 months off, however long, and
Okay,
still be
okay.
good. So
Exactly. And that's enough time to definitely change your situation. So
uh-huh.
so no fret with that. And that actually goes to, anybody in this course, since I'm still recording, anybody in this course feels that they want to go through the program that I went through, which is Ashton, then I'm more than happy to pass that connect and refer you. And they will probably more likely take you on because I was really like a good contractor with them. They really loved me because I did my work. And I took whatever they gave me as far as pay because I knew that I was here to learn first. I knew that I was just going to take this information and 10x it. I already had a plan.
Correct.
I was using them as they were using me, right?
Mm-hmm.
So what I kind of want to do is make sure people have that same mindset that this is not for you to stay with them long term. This is just for you to learn so you
Right.
can
Correct.
you can get the network because they are going to put you into the position to where now you know how to move and do it on your own. I feel like if I didn't have them, then I wouldn't have the knowledge to negotiate an interview to have $75 an hour, to have $100 an hour, because it's just certain ways you have to be in an interview. I understand you have all this knowledge, but it's a certain personality, it's a certain reference, like who did you come from? A lot of times they do not hire you just because you put the application in. Someone has to refer you. Like it's really a networking game. Like,
Right. Uh-huh.
so I was grateful to have that network, to build a network outside of them. And now I can spread that network to you guys because I have at least a couple people on my team that work in the industry and, can give you guys jobs. But, a lot of times they want either for you to have the CCNA or they want you to be able to speak to this
The
type of
language.
technology.
Yeah.
Yeah,
Mhm.
yeah. So that's what I'm trying to get you guys to get. Either get this CCNA or speak to it so you can have interviews with my people and they can just be like, cool, I mess with Jess. I like her. I like what she got going on. So because of her, I'm gonna put you on. Right. That's usually how that goes.
Oh, yeah, word
Yeah.
of mouth. That's just how what I'm doing now with my contract work. It's word of mouth. One
Yeah.
contract, go to the next contract. Oh, you want this contract? We all go to this contract. Yeah.
Yep. So
Okay.
that's exactly how that is. So I just want to make sure that you guys are set up for success because even if I can just rush you into a position, you probably won't succeed if you are
Correct.
not, doing what you need to do. So yeah, I'm here for you. I cannot stress that enough, you guys. I have 45 people in the class and there's only about 5 people that consistently reach out to me. And I want those numbers to change. I really do. I would rather at least half of you guys, 20 students, come reach out to me and, we move forward with their careers. But it's okay, if even if I only impact one, which, I was able to, impact a little bit on Adele. She works for Meta, so that's pretty cool. She was able to go to Ashland, she was able to go to California and travel. So, that was one. I would like to, have someone else to go out and travel and, get their first tech job and do what they need to do. So yeah, thank you
Okay.
guys for showing up.
Thank you for having this for us.
For sure.
Yeah,
For
thank you
sure.
so much.
Definitely welcome. Have a good Saturday, you guys, and I will see you guys tomorrow.
Okay, you too.
All right, you
Thank
too.
you.
Take care.
You too. Bye bye.